Hello everyone and welcome to Java Basics. Today we'll explain one of the most important concepts in Java, object-oriented. I won't cover everything since this is a large subject, but I'll try to implement this in the World demo in a way that will show you why object-oriented is important and useful. I will also talk about important concepts like records, immutability, and more. There's a lot to cover. This is the code from the last video, which is our starting point. Today's code is in this URL. It too is in the video description, so you don't need to copy that either. Up until now, we created the default IntelliJ IDEA project type. This worked reasonably well for simple Hello World application types. But in this tutorial, we want to do more, so we will create a Maven project instead. When we create a project in the IDE, it knows the files we added to the project and how to build them into an app. Maven is a standard project type that is IDE neutral. It can work with other IDEs, not just IntelliJ IDEA, but it has many other features. You can add a library to a non-Maven project, but Maven lets us define dependencies. Let's say another developer writes code we want to use. Typically, that developer will package that code into a library that we can use. But what if that library needs another library, which needs another library, which needs a library that must be a specific version? This is where things start to get difficult. In Maven, we can define a dependency, and it fetches everything we need. It will fail if there's a conflict. It's highly customizable. There are other alternatives to Maven, such as Gradle. Maven is older and still more popular, so I'll focus on that. Notice that if you understand Maven properly, then you understand Gradle too. They are similar conceptually, although the syntax is very different. Let's start by creating a project. We start in IntelliJ IDEA by clicking the File, New Project menu item to launch the new project window. If you look at this dialog, you will see three options where I point at with the mouse: the IntelliJ project, which is what we used until now, Maven, or Gradle. We'll pick Maven. Next, we need to enter the project name, which in this case I'll type out as Wordle Maven to keep it unique from the other projects, but there's still more we need to do. In the advanced section, we enter the group ID and artifact ID. These are unique names used to discover and define our project. These are just names, but they're also used for the packages in the project. Notice I used the group ID com.debugagent. I own the website debugagent.com. It's a common convention popularized by Java to use the domain name in reverse order to guarantee that your name is unique to you. At this moment, this isn't a big deal since you won't ship this application, but it's very important to name things well if you want other people to use them. This avoids conflicts. Once we did that, we can click the Create button. This pops up the prompt of whether we want to reuse this window or use a new window. I usually pick new window, but there's no wrong answer here. The most obvious new feature in the code is the first line, the package statement. Up until now, we wrote all our code in the default package. This is considered bad practice in Java. Imagine if all developers wrote their code in the default package. Pretty soon the project will be filled with code you wouldn't find anything. We need order. Packages are an important way to organize our code. In fact, when we write the import statements, we import a class from a package. This means that if another developer would import this class, they would need to write import com.debugagent.main. Packages have many other capabilities that we'll dig into later, but there's one other change to focus on. We have a pom.xml file. This is where we write the Maven project definition. I'll visit this file soon enough. But first, let's paste in the code from the previous project. So we'll start from where we left off. Notice that even though I pasted the body of the main IntelliJ IntelliJ is smart enough to also add the required import statements. Next, I paste in the two files from the root of the previous project, and I can now run the project just like before. Nothing changed as far as I'm concerned right now. I can switch to the POM file where we can see the structure of the project. The POM file uses the XML format to describe the project. We can edit it like we can edit regular Java source files. For now, I'll leave it as it is, and go back to the code. Before we proceed, main is a terrible name. The application we have here is Wordle. In the right-click menu, I can find the refactor option. Why is this a refactor and not just a rename? Refactoring in programming means that we change not just the current name of something, we also change everything related to that. In this case, no one uses main other than us, but it's both in the file name and the class name. It will update both of those. In other files, if other files used main, it would have updated those files too and fixed the reference to Wordle. Now I'll create a new class. Why do I need one? I want a class to represent every entry in the list of strings we created the last time around. Otherwise, it will be difficult to deal with all those strings individually. I'd rather have a list of objects that includes the values as I need them. I will create a new class and call it state. I will then add fields to represent every element in the state, every part of the string we read, today's word, the timestamp, and the list of attempts that the user tried to guess. This corresponds exactly to the things we wrote in the last time around. Notice that all the fields here aren't static. These are instance fields. That means we can create many instances of the class state, and each one of them can have different values for the fields. If I had defined these as static, they would have had the same value for every row. Notice another thing. I made all the fields public, and that's a problem. This brings us to the most important concept of object-oriented programming, commonly known as OOP, encapsulation. In object-oriented programming, we see everything as an object. An object has properties, which in our case are our fields. We can also invoke operations on it. These are our methods. It has three core concepts, and encapsulation is the first. It means that an object should hide the implementation details. Part of that is hiding the fields. They shouldn't be public. If they are public, another part of the code can change them. Then we might have a problem and we won't know which class caused the problem. By using encapsulation, we divide responsibility in a sensible way. State is responsible for its own variables. Our solution is to use private fields. But then how do I use the class? We need to change the fields after all. The solution is so common that there's a refactoring for it, conveniently named encapsulate fields. It creates getters and setters for all the fields. These are methods named getFieldName and setFieldName respectively. They let you change the field value or get it. This lets us bind functionality to field changes or fetches. I can write code that doesn't let you change the word to a word of an invalid length. This encapsulates, but it's pretty problematic form of encapsulation since it maps to the state. There are several better approaches we can take, but the common best practice is to make the fields final. Final fields and variables can't be changed. They must be assigned when created and can't be modified after that. As you can see, this raises a problem. I made all the fields final and now they all show an error. I created a final field and didn't assign a value. Luckily, Java is pretty patient when it comes to final field. It lets us assign them in the constructor. A constructor is a special kind of method that you can't invoke directly, but it gets called when the object is created. I press the Command N key combination, which in Windows would probably be Control N. Here I'm given the option to generate code like setters, getters, and a constructor. I can just type in the code, but this is a bit faster. I select constructor. I select all the fields as parameters to the constructor. This means that when I write a new state, I will need to pass all the values to the fields. This is essential since I made all the fields final. The constructor has the name of the class. That's how we know it's a constructor. It has fields as arguments and assigns them to the final fields. Notice the syntax that starts with this.fieldName. Java has a keyword called this. It carries with it the instance of the current object. Notice that since the argument name has the same name as the field, how would Java know if we're referring to the argument or the field name? We can use this to be explicit about meaning. Here we assign into the field on the left-hand side from the argument on the right-hand side. Finally, we remove all the setters. Notice that they don't compile anyway since they try to assign to final fields. So we can't even assign a bad value by mistake. We created an immutable class. An immutable class is a class that can't be modified after it was created. String is immutable. This is a powerful concept in programming, and the common wisdom is that it reduces the chances of programming errors. Now, you might look at this and think, this is a lot of code for something so simple, right? Yes, we all did. That's why Java 14 introduced records. Records convert all of this code to a single entry, an immutable class with a constructor that initializes the values. The only difference is that instead of getFieldName method, the record has a fieldName method. It's a very powerful yet simple tool. So how do we use it? Let's go back to the Wordle class and start by changing the values we want to a list of state objects. Once we do that, the data will no longer work since the readLines code returns a list of strings. We can use the Stream API like before to convert strings to state objects. We start by going to the end of the current statement. We start off with the stream and map every entry in the list of strings to a new state. We did this before, but as a reminder, the block within the map is called a lambda, and it will be invoked for every entry within the list. Here we can return the state object instead of the string representing a line. Each line includes several strings separated by a comma, so we can break that string down to a string array. The split method of the string does that for us. It breaks down the string based on the commas, so we can get individual strings. So for a string like this, we'll get an array of the 4 strings without the commas. The 0 element will be the timestamp, and the actual word of the day, and finally the strings the user tried to enter. The first value is a number, so we need to convert it to a long value. To do that, we have a class called long, and it can parse such numbers. The second value is the word of the day. We can save it to a variable and proceed. I could just pass the array to the constructor, but I wanted the code to be more readable, so I did it this way. Finally, we need a list of strings. I can create a new list and add the values to there, but this isn't as convenient. Instead, we can use the arrays class, which has a method that converts an array to a list. But there's a problem with this code. The new list also includes the first two elements. We want a list that doesn't include them. How do we do that? We can use the sublist method to return a list that includes only some of the elements. We give it the index range. The starting index is 2, as we don't want the first two elements. The last index is the same as the length of the array. This will produce a list that doesn't include the first two elements. Now that we can finally create an instance of the state record, we pass the arguments to the constructor in the same order we declared them. Notice that this works with the new keyword and doesn't work with like normal method invocation. We return the newly created instance to the map class. Finally, we can generate a list from the stream and return that. This resolves the problem in the compiler and the code will run. If we want to access an individual entry, we will have a convenient object and will no longer need to write all of it, all of this code to just get a timestamp. We can just invoke the time method on the state object and we will get a ready-made value. Finally, this was a bit long because I took the long way around in the hope of explaining why the shortcut is valuable. In the next video, we will discuss the value of JSON and how we can remove a lot of this complexity seamlessly. If you have any questions, please use the comment section. Thank you.